Depth Charge here for another math tutorial video, and today's topic is going to be the 6 trigonometric ratios. Before I get started, let me ask you to please consider subscribing, hitting that thumbs up button, and considering subscribing and checking out my other channels. Links are in the description. The 6 trigonometric ratios are exactly what they're described as. They're ratios that are specific to a specific type of shape. Right triangles, and in any right triangle you've got 3 sides, and you are able to make ratios of all 3 sides in 6 different ways, and that's why there's 6 different names to these 6 trig ratios. Sine refers to the opposite side divided by the hypotenuse. And I'm going to be writing, as I go top to bottom on the page, I will illustrate what I mean by opposite and hypotenuse in a picture below this word right here. So, opposite over hypotenuse. You've got to identify the opposite and the hypotenuse of a triangle, and you make a ratio, and that is what we call the sine ratio. The cosine ratio is the adjacent side divided by the hypotenuse. The tangent side is when we make a ratio of the opposite side divided by the adjacent side. The cosecant is related to one of the previous 3. These are not as well known: cosecant, secant, and cotangent. Cosecant is related to sine. It is the reciprocal, which is the hypotenuse divided by the opposite. Secant is the hypotenuse divided by the adjacent. And finally, cotangent is the adjacent divided by the opposite. And those are the 6. Now, there's an easy way to hopefully memorize that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And there's a number of ways that we do it. I call it SOHCAHTOA. Others have other wording for it. But I did promise a picture below the word cotangent to describe what the heck opposite and adjacent hypotenuse mean. So if we consider a triangle, it's got an angle. This is the opposite side. This is the adjacent side. And that's the hypotenuse side. SOHCAHTOA. SOHCAHTOA means that sine is opposite over hypotenuse. So we can say that sine theta is the opposite side over the hypotenuse side. Cosine theta is the adjacent side over the hypotenuse. And finally, tangent of the angle, there's the angle, and this is a right triangle, is a ratio of the opposite side over the adjacent side. I just barely fit that in. So, sine of an angle. The angle is unknown. It will remain unknown for this entire video. The angle is not what matters. What matters is the ratio. Sine is Opposite over hypotenuse, cosine is adjacent over hypotenuse, and that's exactly what this says. Awesome. Let's use that to do two problems. Here's my angle, here's my triangle. All 6 trig ratios are what we want. Sine is what is usually done first, sine of the angle. Now, what am I doing the sine of? This is what's called a function. This is what's called the input. And so what comes after the equal sign is the output. The output is opposite over hypotenuse. The opposite is 4, and the hypotenuse is 5. By the way, the hypotenuse is always the longest side of any right triangle. And that's it. This is the output. So, if you're ever asked this question, you will hopefully have a very good answer to it, and that is, what is the purpose of sine? The purpose of sine is to, if you input an angle, in this case it's an unknown angle, sine outputs a ratio, and that ratio is the opposite side over the hypotenuse side. Five more to go. Cosine of the angle is going to be the adjacent side divided by the hypotenuse. The adjacent side is 3. The adjacent side is adjacent, that's why we use that word, to the angle. 5, which is the hypotenuse, is also adjacent, but it's not the adjacent, it's the hypotenuse. 3/5. And that's it. Tangent of the angle is the opposite of the adjacent, which is 4/3. And there it is. 3 more to go, which is the reciprocal of these 3. The reciprocals, the order I did, is cosecant, secant, and cotangent. Notice that I abbreviated sine, S-I-N-E, with S-I-N. I abbreviated cosine with C-O-S, and I abbreviated tangent with T-A-N. I'm going to abbreviate the reciprocal of sine as cosecant, C-S-C. C-S-C is the reciprocal of sine, and it's 5/4. Also known as hypotenuse over opposite. The reciprocal of cosine is S-E-C, secant. This is an input, this is the function, the output is the ratio, which is the reciprocal of cosine, 5/3. And finally, cotangent is the reciprocal of tangent. Like I said, secant, the full word is here. Cotangent, the full word is here. Cosecant and secant and cotangent are long words, so we abbreviate them. This is what the ratios are. Cotangent of the angle is going to be 3/4. Which is the adjacent side divided by the opposite side. Find all 6 trig ratios. There they are. 1, 2, 3, 4, 5, 6. And that's it for that problem. 1 more to go. And it's the same problem with a different triangle. Find all 6 trig ratios. But the location of the angle is different, and the triangle is oriented a little bit differently. I like to write this down, S-O-H-C-A-H TOA to guide me. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. The reciprocals are just that. The reciprocal of this would be hypotenuse over opposite. The reciprocal of this would be hypotenuse over adjacent. The reciprocal of this would be adjacent over opposite. There's a problem. What's the hypotenuse? Call it C. Call it whatever you want. 1 squared plus root 3 squared equals C squared. That is from Pythagorean theorem. A squared plus B squared equals C squared. So 1 plus 3 equals C squared. 4 equals C squared. Common sense should tell us that C equals 2. Because 2 squared is 4. So that is the hypotenuse of 2. Hopefully I have just enough room to the side here to do my 6 trig ratios. Sine of the angle. And the angle is definitely not that symbol. You got to be careful. Sometimes different letters are used for the angle. This is a Greek letter. Sine of the angle is going to be the opposite, which is root 3, divided by the hypotenuse, which is 2. And that's it. It's simplified. It's good to go. Cosine of the angle is going to be the adjacent side 1 over 2. Tangent of the angle is going to be the opposite side, which is root 3 over 1, and we don't leave it like that. It's just root 3. So, I'm halfway done. The goal is, and the question's kind of cut off, but I did that so I have the room here. The goal is to get all 6 ratios with these 3 side lengths. I'm halfway done, but you got to be careful when you reciprocate these. From the previous page, the reciprocal of this is a new ratio, and it's called the cosecant. The reciprocal of this is a new ratio. It's called the secant. The reciprocal of this is a new ratio. It's called the cotangent. The CSC ratio is going to be 2 over root 3. And that's a problem, unless you're in calculus. If you're in pre-calculus or algebra 2 or any other course besides calculus, you can't leave it like that. You have to multiply it by the equivalent of 1. This is a topic for another video. Totally different lesson. Multiply it by 1. Why did I choose that 1? For another time. And you get 2 root 3 over 3. And that is the correct answer in pre-cal and algebra 2 and other courses besides calculus as to what the cosecant ratio is according to this triangle. SEC ratio is much easier. It's the reciprocal of this, otherwise known as hypotenuse over adjacent. So it's going to be 2 over 1, which is just 2. Do not leave your final answer as 2 over 1. Final ratio is the cotangent, which is the reciprocal, which would be adjacent over opposite. 1 over root 3, same problem as before. We fix it by multiplying it by root 3 over root 3, which is root 3 over 3. And that is it. I've got 3 side lengths of a triangle. I made 6 ratios. And notice that I put the reciprocals next to each other. It's very good to organize it that way. Before I got all 6 trig ratios, I had to do Pythagorean theorem. You're not always going to be given all three sides at once, because if you're given two sides, you can find the third side. And you may not be given Pythagorean theorem either. You have to memorize it in some cases. Thank you for watching this video, and please leave your thoughts, any questions you have in the comments section. Depth charge out.